Stop. The Earth beneath your feet is plummeting at a crazy speed of 30 kilometers per second, but you'll never hit the bottom. Why? Because in space, the concept of down doesn't even exist. There's no floor, no ceiling. The very idea of falling down is actually the biggest lie your brain has ever made up. What's even more terrifying is that right now, you're riding on a cannonball weighing 60 trillion tons, racing around the sun at 30 kilometers per second. Fast enough to fly from Beijing to Shanghai in just 1 second, yet you don't feel any shaking at all. Here's the question: why doesn't the Earth just break free like a wild horse and fly straight out of the solar system? The answer lies in an equation that Einstein spent his whole life trying to fully solve. He said that space itself is curved. The Earth isn't just floating in space, but is actually spinning wildly along an invisible deep pit carved out by the sun. This is the most brutal truth of the universe. Picture this: you place a bowling ball on a tightly stretched trampoline, and the trampoline immediately sinks, forming a huge pit. Now, if you roll a marble from the edge, what will happen to it? It won't just stay put. Instead, it'll slide wildly down the dip toward the bowling ball. But if the marble has enough sideways speed, it won't fall straight in. It'll circle around the bowling ball, never actually hitting it. That's the true relationship between the Earth and the Sun. The Sun's mass is 330,000 times that of the Earth. It creates a bottomless black hole-like depression in the fabric of space-time around it. And the Earth, like that fast-spinning marble, has been sliding in this invisible pit for 4.6 billion years, never once falling in. But what's even crazier? In fact, the Earth is constantly falling toward the Sun, but at the same time, it's desperately trying to escape sideways. The speeds in these two directions perfectly offset each other, so the path the Earth traces ends up being an almost perfect circle. Scientists have calculated that the eccentricity of Earth's orbit is only 0.017. What does that mean? It means that the Earth's orbit around the Sun is even more precise than a circle drawn with a compass. This level of accuracy is almost insane, with a margin of error of less than 2%. So just how fast is the Earth moving right now? 29.78 kilometers per second. What does that mean? A sniper rifle bullet travels at about 1 kilometer per second, but the Earth is moving 30 times faster than that. If you stand still on the Earth, after 7 minutes, you will have traveled 12,600 kilometers through space, which is about a third of the way around the Earth's equator. But why don't you feel anything at all? Because you, along with everything else on Earth, including the air, the oceans, buildings, and cars, are all racing along at the same speed, and there's nothing to serve as a reference point to tell you that you're moving. Now here's the question: what would happen if the Earth suddenly slammed on the brakes? The answer is the stuff of nightmares. NASA scientists have calculated that if the Earth's orbital speed were to suddenly drop to zero, in just 65 days, the Earth would shoot straight into the Sun like a cannonball. What would happen before that? In the first week, Earth's temperature would start to rise dramatically, because we would be getting closer and closer to the Sun. In the second week, the oceans would start to boil, and the atmosphere would begin to burn. By the third week, surface temperatures would exceed 300 degrees Celsius, and all life would perish in the extreme heat. By the ninth week, the Earth's surface would have turned into a sea of molten rock, with all buildings melted away. All structures in the ocean melt and evaporate. On the final day, Earth plunges into the Sun's atmosphere at a speed of 617 kilometers per second, and within less than 10 seconds, it is completely torn apart and transformed into high-temperature plasma. But you can rest assured, this kind of thing will never happen. Why? Because in space, there's simply nothing that can make the Earth stop. The environment in which Earth moves is an almost perfect vacuum, with an air density 1 trillion times lower than at the Earth's surface, and friction is nearly zero. The speed that Earth acquired 4.6 billion years ago has barely diminished to this day. It will keep spinning until the day the Sun dies. At this point, you might ask, where did Earth's original speed come from? The answer goes back 4.6 billion years. At that time, in a certain corner of the Milky Way, there was a massive cloud of gas and dust, which scientists call the Primordial Nebula. This nebula began to contract under its own gravity, and as it contracted, it started to rotate. Why did it start to rotate? Because matter in the universe naturally possesses angular momentum. This is a physical law called the conservation of angular momentum. Simply put, once it starts spinning, it can't stop anymore. Just like a figure skater who spins faster when they pull in their arms, the Primordial Nebula did the same. Its rotation speed increased dramatically as it contracted. Eventually, the center of the nebula formed the Sun, while the surrounding debris coalesced into the 8 planets. Earth inherited the rotation of that nebula, spinning wildly from the moment it was born, and that speed has been maintained to this day. But here's a harsher truth. The fact that Earth has survived to this day is actually the result of a massive cosmic selection process. When the solar system first formed, there were thousands upon thousands of asteroids and fragments around. Those moving too fast were flung out of the solar system, while those moving too slowly fell into the Sun. Only those with just the right speed could survive. Earth was the lucky one. How low were the odds? Astronomers have calculated that in the early days of the solar system, the probability of a planet being able to maintain a stable orbit until today was less than 1 in 1,000. The fact that Earth has survived for 4.6 billion years is a miracle in itself. What's even more astonishing is that over 300 years ago, Newton predicted all of this with a thought experiment. He imagined placing a cannon on top of a very tall mountain and firing it toward the horizon. If the cannonball's speed is low, it will follow a curved path and fall back to the ground. If its speed reaches 7.9 kilometers per second, the cannonball will keep falling downward, but it will never hit the ground because the Earth is round. As the cannonball falls, the ground curves away beneath it, so the cannonball keeps circling around the Earth. This is the principle behind humanity's first artificial satellite, and also the principle behind Earth's orbit around the Sun. Essentially, the Earth is just a natural satellite of the Sun. Now comes the biggest question: can this balance last forever? The answer is no. In fact, the Earth is slowly moving away from the Sun at a rate of 3.8 centimeters per year. The reason is complicated, but mainly it's because the Sun is constantly losing mass. Every second, 4 million tons of matter are converted into energy and radiated away through nuclear fusion. As the Sun gets lighter, its gravitational pull weakens, so naturally the Earth drifts outward. At this rate, in a billion years, the Earth will be 38,000 kilometers farther from the Sun. Although this distance isn't huge, it's enough to lower the Earth's average temperature by 2 to 3 degrees Celsius, which could trigger a new ice age. But the real crisis will come in 5 billion years, when the Sun runs out of hydrogen fuel in its core and begins to burn hydrogen in its outer layers. It will begin burning the hydrogen in its outer layers, expanding to 200 times its current size and becoming a red giant. At that time, the surface of the Sun will extend close to the orbit of Mars, and Mercury and Venus will be directly engulfed. Although Earth might escape being swallowed, it will still be scorched into a charred ball of rock. Its oceans will evaporate, its atmosphere will dissipate, and all life will become extinct. This is the ultimate fate of the solar system. To sum up, the reason Earth is suspended in space without falling is due to 3 key factors. First, there is no absolute up or down in the universe. The very concept of falling is actually a misconception. Second, the Sun bends the surrounding spacetime with its mass, creating an invisible gravitational well in which the Earth moves at high speed. Third, the Earth has enough lateral velocity so that as it is constantly falling, it is also constantly escaping, achieving a perfect balance between the two. This system has been operating for 4.6 billion years with an astonishing level of precision. And we humans live on this high-speed flying planet, constantly traveling through the universe every moment, yet completely unaware of it. This is not a miracle, it is the law of physics. But it is precisely these cold, unfeeling laws that have given us a warm home, allowing us the chance to gaze at the stars and ponder the meaning of it all.